Hello students and welcome to Chemistry 1A. We are starting with Chapter 1, which is the study of the change. This is definitely coming from the definition of chemistry. Chemistry can be defined as the study of the matter and the changes it undergoes. We are going to be reminding ourselves of the three states of the matter. Matter can either exist as a solid, where the particles are very compact and sitting so close next to each other with no motion. Liquids, the distances between them gets a little bit larger and they start to have some kind of vibration or motion. And gases, when the distances between the particles are so huge and they are definitely moving very fast. We also can classify matter as a pure substance in which we only have one kind of atom or a molecule. For example, copper is considered to be a pure substance. A pure sample of only water is also a pure substance. A pure sample of carbon dioxide is also a pure substance, and so on. A mixture is made of different kinds of atom, molecules, or variable composition. For example, the air is a mixture. It is made of oxygen gas, nitrogen gas, carbon dioxide, some argon, and some vapor, and so on, in different variable composition. So this is the air. It has multiple pure substances, and therefore we consider it to be a mixture. We are also going to look at the changes and try to classify them as either physical or chemical changes. A physical change, a change that happens to the appearance of the same substance or the state of the same substance. For example, if you melt ice, all you are doing, you're taking water from solid ice into water liquid. It's still the same composition, it's still water, and therefore this is a physical change. Also, if you have a big piece of paper and you cut it into little pieces of paper or shred it into little pieces of paper, it is a physical change. You only change the appearance, but the composition stays the same. Ice melting, if you dissolve sugar in water, sugar will keep its composition, water will keep its composition. So this is a physical process as well. A chemical change is when reaction, and this is when we form a new substance, and which means we definitely are changing the composition. So for example, if we are to burn hydrogen in the air, so these are here the particles of hydrogen, and this is like particles of the oxygen in the air, then we are gonna get a new product, which is the water molecule. The water molecule is a different composition and different property, so we made something new that was not there before we started. Another way to look at it is, if you cannot take it to what it used to be, then it is a chemical change. For example, when you bake your cookie dough, then that baking process is a chemical change because you cannot take the cookie to be a cookie dough again. And if you cook chicken, you cannot uncook it, so that's a chemical change. You did change the composition. However, if you evaporated water, you just took it from liquid to gas, and it is reversible. I can condense gas back to liquid. So if you can return it back what it used to be, then that is physical. Also, properties can be classified as extensive or intensive properties. And extensive properties depends on how much matter is there. So for example, mass is an extensive property. So if you have a small amount of a matter, it will have a different mass Then if you increase that amount, it will depend on the amount. So mass, length, volume are all considered to be extensive properties. However, intensive property does not depend on how much matter is there. An example of this will be the color. The color of a substance should not change whether you have a small amount of a substance or a large amount of the substance. The temperature of water in the ocean will be the same whether you measure it while it is in the ocean in a large amount, or if you pour some in a small little bucket and you measure the temperature will not change depending on the quantity. Now we're going to look at measurements and why we always need to have numbers and unit to describe them. I'm going to read the following for you. When my son was 7, he walked 3, and when he was 4, he threw his baseball 8, and said his school was 5 away. The reason this sentence does not make much of a sense, it's because those numbers do not have units. And without units, numbers are meaningless. So let's see what happens when we introduce units to that. When my son was 7 months old, he walked 3 steps, and when he was 4 years old, he threw his baseball 8 feet and said his school was 5 minutes away. Now the whole sentence makes way more sense. Units will be either in metric system or international system of unit, which is unifying the units. So let's look at that. You need to know all the units, their abbreviation, and what is the SI unit for mass. So for example, for mass it's a kilogram, for length is a meter, time is a second, temperature is a Kelvin, mole for amount, and so on. You also need to use prefixes and know exactly what do they mean quantity-wise. They are used to describe large amount. So for example, a kilo of anything is 1,000 of that thing. When we say this person makes 98K a year, we are really saying 98,000. So K here is kilo. Mega is 1,000,000 of anything, and giga is 1,000,000,000 of that thing, and so on. Please pay attention that it is very important that you know the symbols used to express each prefix. So also when it comes to fraction, a deci is 1/10, a centi is 1 of 100, a milli is 1 of 1,000, a micro is 1 of 1,000,000, and so on. Measurements. For length, the SI unit is meter. However, we also use US units like yard, and there is an exact conversion between inch and centimeter that we all need to know by heart. An inch is equal to 2.54 centimeters. Also, a mile is equal 1.609 kilometer. Everything I am providing to you here are conversion factors that you need to memorize to be able to solve problems later in the semester. Mass is amount of matter. The SI unit is kilogram. You need to know the relationship between the pound and the grams. There is almost 454 grams in every pound. Weight is different from mass because weight is the force that gravity exerts on an object. So mass and weight are not the same thing, right? Mass is the amount of matter, but weight can change depending on the gravity. Volume is defined as the amount of space occupied by an object. The SI unit is a cubic meter, and that comes from the fact that volume is considered to be for a regular shaped object is length times height times width. So all of them are length units, which is meter for the SI unit. So this is why it's a cubic meter. You also need to know that a liter is equal to 1 cubic decimeter, a milliliter is equal to 1 cubic centimeter, a gallon is equal to 3.785 liter. These equipments that you see on this slides are equipments that measure the volume of a liquid, like a graduated cylinder, syringe, burette, pipette, and volumetric flasks. When it comes to temperature, there are 3 different scales for temperature. Temperature does measure how hot or cold an object is. The SI unit, please remember, it's Kelvin. It's not a degree Celsius, it is Kelvin. So, look at the 3 scales here. We have the Kelvin scale, we have the Celsius scale, and the Fahrenheit scale. If you look at this picture, then you will see that water freezes at 273 Kelvin, which is equal to a 0 degree Celsius and a 32 degree Fahrenheit. And it does boil at 373 Kelvin, 100 degrees Celsius and 212 degree Fahrenheit. It's also worth noting that the degree Celsius and Kelvin are divided into 100 graduate between the freezing point and the boiling point. While it is a different story when it comes to the degree Fahrenheit, which is divided to 180 degree intervals between the water freezes and the water boils. Therefore, conversion from degree Celsius to Kelvin will be easy. All you have to do is to add 273.15 to the degree Celsius. Please note in this class that if you just added the 273, I will definitely be okay with that. When it comes to the degree Fahrenheit, if you want to derive it from the degree Celsius, you need first to multiply by 9/5. If you want to know where 9/5 come from, it does come from 180 degree intervals over 100 degree intervals for a Celsius. So this is Celsius and this is Fahrenheit. So it comes down as 9/5. So you convert Celsius into Fahrenheit and then you add a 32. And the reason why you add a 32, because the starting here for a Fahrenheit is 32, which is equivalent to the 0 degree start for a degree Celsius. Now, I'm going to write down for you how do you get a degree Celsius from Fahrenheit. So what you do, you get your degree Fahrenheit and you subtract the 32 as the start first, and then you multiply that by 5/9, and this is how you get your degree Celsius. Now it's time to have some fun and practice for your own benefit how to convert the followings: Kelvin to degree Celsius to degree Fahrenheit, and degree Fahrenheit to degree Celsius. This will conclude this lecture, and I will see you in the next topic.